A massive rotary cement kiln dominates the factory floor, rotating continuously on heavy steel support rollers. At one end, a powerful burner fires constantly, generating extreme heat deep inside the rotating kiln. Inside, temperatures rise beyond 1400 degrees Celsius, turning the kiln interior into a glowing thermal zone.
Thick, refractory brick linings shield the steel shell, surviving constant rotation, pressure, and sustained extreme heat.
This kiln operates non-stop for months, transforming raw minerals into clinker without cooling or shutdown.
Crushed limestone and clay enter the kiln inlet, beginning a slow transformation driven by heat and rotation. As the kiln rotates, raw material slowly advances inward, lifted and dropped repeatedly by internal geometry. Moisture evaporates early, leaving dry material that moves freely along the rotating kiln surface. Temperatures continue rising, heating the material evenly as it travels deeper toward the burning zone.
At higher temperatures, limestone begins decomposing, releasing gas while its structure changes permanently.
This chemical breakdown prepares minerals for bonding, setting the foundation for clinker formation ahead.
Approaching the burner, temperatures intensify sharply as material enters the kiln's hottest zone. Here, partial melting occurs, allowing minerals to fuse and begin forming rounded clinker nodules. Continuous rotation shapes these nodules naturally, preventing sticking while ensuring uniform size development. At peak temperature, the burner flame stabilizes the reaction, maintaining consistent clinker quality. Fully formed clinker moves steadily toward the outlet, still glowing from intense internal heat. Gravity guides the clinker downward as it exits the rotating kiln shell. Fresh clinker lands on a conveyor, transferring heat away while maintaining continuous material flow. Despite extreme temperatures, upstream feeding continues, keeping the kiln fully loaded at all times. This balance of input, heat, and rotation allows the kiln to operate continuously without interruption.
Red-hot clinker enters the cooler, where powerful air fans begin reducing temperature immediately.
As temperature drops, clinker hardens further, locking in its final physical structure.
Recovered hot air is redirected back toward the kiln, improving overall thermal efficiency.
Mechanical crushers reduce oversized clinker lumps before further handling. Continuous monitoring ensures clinker temperature remains safe for downstream equipment.
Controlled airflow inside the cooler maintains stable cooling without damaging clinker quality.
Gradually cooled clinker exits the cooler, now safe for long-distance mechanical transport. Mechanical crushers reduce oversized clinker lumps before further handling.
From here, clinker flows continuously toward storage without interrupting kiln operation.
Crushed clinker drops onto enclosed conveyors, moving steadily toward intermediate storage systems.
Large storage silos receive clinker, allowing production to continue even during downstream maintenance. Inside storage, clinker settles naturally, forming stable piles ready for controlled discharge.
Automated gates regulate clinker withdrawal, maintaining consistent feed for grinding operations. Throughout cooling and storage, kiln feeding continues uninterrupted, preserving steady production balance. This seamless cooling and handling stage protects equipment while keeping the kiln running non-stop. Cooled clinker is fed into the grinding mill, where rotating components begin size reduction. Inside the mill, steel grinding media crush clinker repeatedly, breaking it into finer particles. As grinding continues, material flows through chambers designed to refine particle size gradually.
Gypsum is added during grinding, regulating setting time in the finished cement.
Airflow inside the mill carries fine particles upward, while heavier material remains for further grinding. High-efficiency separators classify cement, allowing only correctly sized particles to exit the system.
Oversized particles are recycled back into the mill, maintaining consistent cement fineness. Finished cement powder moves through enclosed ducts, protected from moisture and contamination. Dust collection systems capture airborne particles, keeping the grinding area clean and stable. Ground cement is conveyed upward, preparing for temporary storage before final packing. Large cement silos receive the finished powder, ensuring continuous flow from grinding operations. Inside the silo, cement settles evenly, maintaining consistent density for downstream handling.
Aeration systems keep cement flowing freely, preventing compaction during extended storage periods.
From storage, cement is directed toward packing lines without interrupting upstream production. Grinding and storage operate continuously, matching kiln output to finished cement demand. From storage silos, cement flows into automated packing machines through sealed feed systems.
High-speed packers fill each bag precisely, controlling weight through synchronized mechanical valves. Filled bags move instantly onto conveyors, preventing buildup at the packing station. Each bag passes an automated check, confirming weight consistency before further handling. Approved bags continue forward, while any deviation is redirected without stopping the line. Robotic arms collect cement bags, stacking them into uniform layers with repeatable precision. Layer by layer, pallets form stable stacks designed for safe transport and storage.
Once stacked, pallets move onto conveyors for wrapping and final stabilization.
Stretch wrapping machines secure each pallet, preventing movement during internal transport.
Wrapped pallets exit the line, now protected from moisture and handling damage.
Inside the warehouse, pallets are positioned precisely, maintaining organized inventory flow.
Automated vehicles collect pallets, transporting finished cement toward warehouse storage zones. Finished cement stands ready for dispatch, while production upstream never slows or pauses.
Storage systems track pallet movement automatically, linking production output with dispatch planning. Loaded pallets are transferred toward outbound lanes, preparing cement for scheduled dispatch operations. Forklift systems position pallets precisely, aligning loads with waiting transport vehicles. Pallets are loaded sequentially, maintaining balance and weight distribution inside each truck. Once secured, loaded trucks move forward, clearing docks for the next shipment.
Dispatch operations continue in parallel, matching production output with delivery schedules.
As cement leaves the site, packing lines remain active without interruption. Upstream systems maintain steady flow, feeding grinding, cooling, and kiln stages continuously. While finished cement ships out, new clinker continues forming at peak temperature. Inside the kiln, raw material still advances, driven by rotation, heat, and controlled input.
This uninterrupted cycle allows the kiln to operate continuously, sustaining cement production around the clock.